early morning of the last day of the show, and look who I find, Newphotonics!
Oh my God. To see you.
Great
How
to
are
see
you?
you again.
Yeah.
I'm doing great. Today is the last day of the exhibition, and in my opinion has been the best OFC since the telecom bubble burst.
Absolutely.
We are the best position in the industry since then. Last year at OFC you shocked the exhibition.
Yes.
What happened 1 year after?
Oh, we're breaking every benchmark. Come, I want to show you in our booth.
Let's go to the private booth. Are we going to the private booth of Newphotonics?
Yes, we are.
Private for me and you and everybody who watches this video. Let's run there. Hello, Yosef, Ben-Ezra. Good to see you again.
Good to see you again.
Joseph,
How are you?
it has been a year. 1 year since you shocked the show showing that you can do with pure silicon 200 gig per lane modulation. What happened in the last 12 months?
Oh, a lot of things. And I'm happy to demonstrate today the transmission of 224 gigabit per second PAM4 signal over 23 kilometers of fiber. This project is done with collaboration in Intel. We are using Intel SerDes, serializer and deserializer. This is Intel transmitter. The signal is launched to our transceiver directly without any DSP. It's transmitted over 23 kilometers of fiber and received by the Intel receiver. You can see the performance of the system. What you see here is the histogram of PAM4 signal. 4 levels are very well separated, and the resulted bit error rate prefect is 210 minus 4.
We like, at Optica, we love live demos, and we see that one thing is to show it in PowerPoint. Here you can see, you can touch 224 PAM4 modulation, real time, and you don't need a DSP.
Yeah, without DSP. And what is the most important, that this is the solution with the lowest latency, because no digital signal processing is involved in the system. Lowest complexity, because there is no DSP, lowest power with very, very good performance.
The whole show this year is on one hand about AI, but on the other about linear drive optics and removing the DSP from the pluggable. This has to be integrated. This has to fit somehow in a pluggable. What is your roadmap?
Our roadmap that we will add to this solution another solution also developed at Newphotonics, and we will resolve one of the major problems of the linear pluggable optics, LPO and LRO solutions. What is the main problem of these technologies? The main problem is the interoperability. What I am demonstrating now, I'm demonstrating the optical link. We are introducing additional 11 dB losses in the RF link. You can see the transfer function in this case falls by at least 80 dB at the Nyquist frequency. And this can be a situation when we are using LPO, because it depends on the host. The distance between the transceiver and host can be different. It can introduce additional losses. And you have not a way to compensate for this because DSP is no more exist in the system. We are using all optical equalization, and now I will show you what happens when the signal is going through our equalizer. This is just optical switch. I will switch it to this position. You can see very flat transfer function. This optical equalizer is programmable filter, and it can be dynamically adjusted to the real channel in real time. So this is only way to achieve interoperability for LPO and LRO solutions.
So you have a silicon photonic based tunable filter acting as an optical equalizer. You have arrays of modulators, you have lasers. Can you fit everything into one pluggable?
Yes, definitely. We have engineering samples ready for delivery.
Can I test them? Do you have actually
Yes.
samples that the customers can test?
Even today. Okay, and the next generation will actually monolithically integrate lasers, modulators, and optical equalizers.
When?
It will be ready at the end of Q4.
At the end of Q4, Optica organizes the PEC Summit, Photonic-enabled cloud computing event. Do you want to see that live? Come to the show. Joseph, fantastic to see you again. I'm at Synopsys. This will be the host of the third edition of the PEC Summit, the Photonic-enabled cloud computing. This year, most of the main decision makers in the biggest decisions to be made on data centers and photonics will be here. Are we removing the DSPs for the next generation transceivers? Are we finding new technologies to enable 800G and 1.6 terabit links? And what about AI? Do we know the challenges that this technology is bringing to our ecosystem?